All right. All right, great. So this is Openstack security.
So I guess this is a little low, so I'll be bending over a little bit. So hello, good morning, welcome to ShmooCon. I'm going to open up with a quick quote that oh wait. Awesome. Apparently I can do it this way. Try and keep these away from each other and avoid chaos. So there's a quick quote that I saw on Twitter the other day that's actually kind of awesome. It's, we used to leak kilobytes, then megs, then even gigs. Now we leak EC2 instances. Someday we'll leak entire data centers. So attribution is Dymaxion. So this is the OpenStack security brief. That URL has a link to the PowerPoint that's available off the internet. The point of this talk is focused entirely on demonstrating to you guys a map, a blueprint, if you will, for if you want to go after OpenStack and attack it, and give you some idea of what we've been seeing from the development side of things in terms of security problems, also deployment side of things. So without further ado, I'll give you an intro. So I did give this talk in case anyone's wondering and gives me crap about it, but in terms of my professional career, I was on the team that helped do the initial development on Nova at Nebula. So Nebula was a cloud computing project at NASA that spawned the Nova component of the initial OpenStack. And then there was the Swift component from Rackspace. The two got merged, and later on you had OpenStack with many, many other services. So this is broken up into three major parts. The first part is structure of OpenStack. The second part is targeting of OpenStack. And the third part is basically response and reaction, defense against the dark arts, so to speak. So first thing that irks me is cloud computing is a terrible, terrible term. It's one of those things like computer science. It doesn't actually mean anything. It's completely worthless. So when you start talking about cloud computing nowadays, you actually have to quickly say to people, what do you mean by cloud computing? Because you've got the VMware guys coming up with terms for cloud computing. You've got people going, okay, does that mean it's software as a service, et cetera. So these are a couple of really terrible definitions I saw, and cloud computing was my favorite definition I've heard over the years. A better term in terms of OpenStack is probably elastic design. So the fundamental goal is scaling horizontally rather than vertically. Distributed services, basically everything has to be able to do end distribution on any system. Standard orchestration APIs, open standards are a wonderful thing, and all states are ephemeral, which is actually harder than it sounds. So OpenStack, about OpenStack. It's an elastic cloud, very similar to Amazon. It was originally developed with an EC2 API, but has its own API now. It's Apache licensed, and because it was Apache licensed, CloudStack was forced to open source theirs as well under an Apache license. So you can say thank you to Uncle Sam for making two of these projects open source. There's an open standards component to it, which was important initially via the foundation, and I'm about to get into an interesting security problem with the foundation, which not quite security, but interesting. It's written in Python. Pretty much everything that comes out of the OpenStack Foundation proper is written in Python or Shell or some variant related to supporting Python. REST APIs pretty much everywhere, and shared nothing message orienting for all of OpenStack as best as can be achieved. So I wrote a blog post called Gaming the Foundation last year, and this year during elections we saw a similar result. So a quick note, there's a component of OpenStack called the Foundation. The Foundation actually has board members and is funded by investment from other companies. What the foundation does is decide what is considered a part of OpenStack. They don't decide what code goes into OpenStack, but they say this component is now really a part of OpenStack, and they do outreach and present a public face. So there's elections held for the user-defined portion of OpenStack every year or so. We just recently had our second set of elections. So This is the OpenStack Foundation membership by company. As you can tell, the companies that have the most members are HP, Dell, and I believe Rackspace is the other big guy. There's Rackspace is green, and random other ones, as well as a large percentage of no affiliation. So the problem with this fundamentally that we're seeing is that we don't know how much of, say, HP or Dell's or Rackspace's people are actually involved in the foundation or just signed up because they heard about it on an internal mailing list. So nothing nefarious is going on. Most of what's going on is just we're really having a noise control problem. If you look at the top company by commits and compare it to the top company by foundation membership, you actually see that some of it doesn't line up. Dell drops off the map. Rackspace is still there, obviously, but other companies appear, Red Hat, Nebula, ISI, not really a company, but there. And if you look at the voting by source, you can see that percentage of people who voted for, say, the Dell guy, Rob Hirschfeld, who's a great person, was 86% were people who were from the same employer. And same is true of another Dell person, an HP person, and a Rackspace person, where it's an incredibly high percentage of their votes came from inside their own company. And since those companies maintain a large portion of the voting populace, it's potentially an avenue for attack for a more nefarious group. This is all inadvertent, but it exposed a problem in our voting mechanisms. So sometimes when you have an open source project, there's a lot more going on than just the technology. It's also the community aspect. So without further ado, let's get into the actual structure. So OpenStack has three major component sets that we're going to discuss here. Core components, clients, and incubated components. Incubated means it's OpenStack supported in terms of access to the development environment and CI resources, but it's not considered an active supported part of the core OpenStack project yet. They have to petition for that later on, and that they're not guaranteed a spot in the actual product. So this is I have a couple links in here called Good Reading. If you download the PowerPoint, these links are worth reading. This slide comes from Ken Peppel's breakdown of Folsom architecture, and he has a great blog post every time a new release comes out that does a very simple breakdown of what OpenStack is. Obviously, you can see there's a lot going on here. The cloud is actually pretty complex. Okay, so I'm probably going a bit fast, so let's try and go slow. So the first thing you need to know about OpenStack is it's not hypervisor related. As far as hypervisor security is concerned, it's hard to talk about because OpenStack supports a ton of different hypervisors. It supports KVM as its primary supported. Most people are using it, but Zen is heavily supported. Hyper-V is heavily supported as a result of Microsoft and CERN, who CERN is actually attempting to roll out a 15,000 cluster deployment on Hyper-V. There are VMware deployments as well. I don't know how well they function, but I know that they're out there. And there's physical layer provisioning, which is now coming in as part of the new release called Grizzly. So the current stable release is Folsom, which is what we'll be discussing, but there are a few things I'll note about the new release that is finalizing this weekend what will be in Grizzly. So I will bring up some interesting hypervisor stuff, probably as anecdotal information. So this is actually a little bit better in terms of a simple breakdown. If you look at it, you can kind of get an idea of what each of the components are. So the compute component is Nova. That was the component that we worked on at NASA. Broken out from that was another project called Glance, which became the image store. The object store would be Swift or Ceph, which is Inktank's object store, which DreamHost and a few other major OpenStack users are using. The identity management guy is Keystone, and network is nowadays Quantum or Nova Networking. Nova Networking is being deprecated, and Quantum should be replacing it. However, there has not been much adoption of Quantum at this point, primarily because it's not completely developed. So block storage is Cinder. Cinder has integration in a number of areas. Our company, for instance, does EBS block storage, so we've actually built our own plugins. Other people have their own plugins for their own NAS, etc. And the dashboard is Horizon. So I'll get into each of these in particular, but you can get a pretty good understanding of what's going on with each of these components. Keystone is probably the one you're most interested in as hackers because it's authentication. Keystone by itself is a REST API. It has two different REST APIs, an admin API and a regular API. Port 5000 and another one on 32,000 something or other. It has a service catalog that contains the endpoints for all of your cloud environment. So you can go to Keystone and say, I need the APIs for Nova, Glance, etc. And that's how most of the clients operate. It backends to SQLite by default, but obviously that's not very functional. Most people are backending it to LDAP or MySQL. There are folks who have backended it to Active Directory, and there are patches. I don't know how well they function in Folsom. I know they worked in Essex. What you should know about that is basically when you're bringing things into a cloud environment, especially in the early days, we discovered problems in terms of people wanting to bring things like Active Directory servers and place them inside of an area where users have IaaS services. So they were kind of terrified of people having that close a view of their authentication stuff. So they built an identity system for authentication. Later on, it became a token handling system for all of the messages that went throughout Openstack. So token generation is incredibly important right now, and there's a lot of work going on changing the way tokens operate inside Openstack. If you look up Adam Young's blog at Red Hat, he's doing a ton of work on trying to change the way we operate with tokens. He's trying to do, get into it later, but he's actually got a PKI implementation that's kind of maybe coming in. We're seeing problems with that, and we'll get back to that later. So Nova is the elastic compute. It operates like EC2. There is an EC2 compatibility API, but it also has its own built-in API. So it has the REST API, the EC2 API, and then there's a metadata API that presents data to instances as they come up, and that's very similar to what Amazon does. Integrates with many hypervisors. It defaults to doing hypervisor control via libvirt. Has integrated volume and network orchestration in Folsom. Both of those are being deprecated. Network in favor of Quantum, and volume in favor of Cinder. So security groups, quotas, zones, flavors, all these things are pretty standard if you do EC2 work in the cloud. You're probably familiar with most of this stuff. Config drive is a special case, and it gave us a lot of trouble when it first came out. It actually has one of the worst vulnerabilities we've seen in OpenStack, but it's been patched since. Config drive is basically a means of doing a libguessdfs injection of data into a running instance from OpenStack. Nova is the ugliest, oldest, most complex code in the project. It is the largest chunk of the code, and it is the one where right now they're doing a lot of cleanup work and trying to bring things out and make sure things operate properly. So Glance is the image store. It's a REST API. It's backed by MySQL. Typo. Stores to local volumes, or it can store to an object store. Pretty straightforward. Quantum is the software-defined networking component that's being built right now. Its goal is to replace Nova Network. I'm not 100% good on this because we don't use it at where I work. We have our own network implementation, and I'll get into the differences about that later. The REST API is pretty standard, follows most of the stuff that we do in OpenStack. It can integrate directly with hardware. That was one of the original design things. I don't know that anyone's done it yet, but in theory, you could have a Quantum agent sitting on a switch that could then be controlled via Quantum. Pluggable networking extensions. I have some charts. We can explain that in a bit. And MySQL backend it again. Cinder volumes, basically the same stuff as before. What's interesting to note is that the original Cinder volumes were LVM stores on specific nodes that ran Nova volume services. There is direct hardware interaction with NAS in some cases, and there's direct integration with soft block stores in some cases. Swift is the object store, and HA proxy load balancer in front of it, REST API, block manipulation on nodes, and software application between nodes. That's basically all you really need to know. And Horizon is the web GUI. It integrates with the REST APIs, integrates with client APIs, uses standard Keystone. Django-based, does not use EC2 APIs, solely OpenStack. So if you use Horizon and you expect an EC2 compatibility, you're going to have incompatibility in things that happen. Someone will deploy an instance with a security group and quota set and a network set in Horizon, and then your EC2 command line utilities will not know how to deal with it. Message buses for messaging between the services. There are two different options currently, RabbitMQ and ZeroMQ. RabbitMQ is the default, the one that most people are using. ZeroMQ is one that my company and several others are using. We'll get into those later when we talk about security of them. Development workflows are important in terms of security because you want to know how code is being placed into the project. We follow a continuous integration protocol. Basically Garrett, then Jenkins. So you submit your code into Garrett. There's a peer review process that occurs. I believe currently it's 2 core reviewers have to review code before it's merged into the project. Jenkins has to sign off in terms of unit testing and general functional testing. And Launchpad's used for bug tracking and SSH key store and all that. It's made available via GitHub, and releases are PGP signed. And then packaging is provided via normal means, which is Red Hat has their own signed packages, Ubuntu has their own, SUSE has their own, and we'll get back to that in a few. Well, I guess right now. Core packages are built from release tarballs. They're not built from the Git repo. And the client packages are built from PyPy tarballs. So there are 2 different specific locations where you can pull stuff for package building. If you try and build packages from Git, you're going to run into a world of trouble, and it's not a supported mechanism. Git releases are PGP signed. For OpenStack, we've recently ran into issues with our dependency sets. Basically, there's concerns raised by some of the team at Debian, basically that there are man-in-the-middle attacks occurring in China right now, where they're replacing the path to GitHub, and there's the potential for injection into your project via the Chinese firewall team. So it's important that all releases are PGP signed in GitHub. Ubuntu, Red Hat, and SUSE. Yep. So that's more information on the China GitHub man-in-the-middle attack. So now on to the fun part, actually destroying OpenStack. So I'm going to go through right now is 3 basic tiers of how you would see a deployment. Obviously, every deployment of OpenStack is different, but there are 3 major workflows that I've seen deployed that are kind of followed. This is kind of what my company does and a few other folks in terms of a layer 3. And by layer 3, what I mean here is there's still layer 2 isolation, but the isolation in terms of the instances that are deployed, the user instances, is done at layer 3. So it's done via standard TCP IP routing. And you can kind of see that where you have a layer 3 router at every stage the whole way down. So a lot of switches are operating as layer 3 routers and ensuring that the path of packets, isn't shared as much as you would see in a non-routed model. The fundamental benefit here is you can avoid VLAN. 802.1q is great, except when you have 4,000 projects all with their own VLANs. And in the early Nova networking days, we didn't have vSwitches deployed on the nodes, so we ran situations where we would do things like deploy Nexus 7000s in a rack because we needed 4,000 VLANs. So that's pretty bad. VLAN exhaustion would of course be a potential area of attack, and obviously with this model, layer 3 means that you don't have to jump out of any VLANs. Makes it easier in terms of that, but harder in terms of it's routed and your subnets would be routed properly. Layer 2 model is the model you see people trying to achieve. The problem with this is right now is in terms of actually achieving this, only Nicira has a functional software product. Quantum's attempting to achieve this and probably will, but it's not a complete solution at this point. Early on in Nova networking days, as we were talking about earlier, we didn't have vSwitches, but we had network managers in either on the nodes, all of them, or inside a single cluster of nodes, and acting as a gateway out. What we used to do is the nodes would hook into a bridge, and then the bridge would then be trunked out and managed on the Nova networking side. So you would trunk out on the bridge, go to your Nova networking controller. Your Nova networking controller would then have firewall rules passing you back and forth between the different VLANs that are available. Nowadays, we have vSwitches and backbone trunks coming off the vSwitches. Pretty straightforward stuff in terms of the model. This I drew this morning because I wanted to add it. It's not really a networking model so much as it is a tiering model, like a nested cloud model. This is something that I've seen before where you have an administrative cloud controlling other clouds. So you can see isolation in terms of cloud clustering. So where you'll have like an administrative cloud that generates the services for deploying other clouds. As we discussed earlier, project-wise, there are components of OpenStack that are not. There are things that you need to run an OpenStack cloud that are not part of OpenStack the project. For instance, physical layer provisioning, your own configuration management, your own mirrors for packaging. These are the sort of things that you would deploy for managing a cloud, and then you would deploy them on an iterative level for each one of your chunks of cloud area. So when you're doing a deployment of a large number of machines, you're probably going to have different machines in different release cycles, different machines that are slowly doing a rollout. You'll do a stage rollout. You'll deploy to one cluster or one availability zone, see how that works for those users. If there's no real problems, you'll deploy to more. So this sort of model was done specifically at one of my old employers for policy reasons. The idea was being able to generate a low policy cloud, a high policy cloud, isolation clouds. This is all before we had things like schedule filtering and availability zones that actually function. But nowadays we have that, but there's still functional stuff here. What you see in a lot of deployments is a get down approach where you'll have an authoritative top-down approach in terms of user-defined data. So your audit path is your user is committing changes into a Git repo that then is being automatically deployed down the chain into all of the underlying operating systems and physical hardware. So your configuration management would generally be stored in Git. Your keys would be stored either in Git or in a key store somewhere. Packages, build definitions would be stored in Git, other things of that nature. And of course, you would have a Garrett workflow or something where you'd have a review process between users. So let's get into the message buses. This should be interesting. So 0MQ is what we use currently because it provides a greater ability to provide high availability in our situation. However, 0MQ basically has no security by design, and it's only recently gotten to the point where you would actually consider deploying it inside of a production node. We've seen a couple of 0MQ vulnerabilities in the Folsom release, related to anyways, and we don't currently have, but should have in the next release, message signing on the 0MQ bus. 0MQ's basic approach to security is implement it yourself, do VPNs or tunneling or SSL, etc., but they also don't recommend anything and basically say none of it works. So you're either encrypting the messages before they go over or you're trying to encapsulate it. This is good reading on the status of the secure messaging. And then RabbitMQ is the one you actually care about because most people are using this. It actually has integrated SSL support, supports authentication via SASL, has public-private queues, and it has no encryption at rest, but really who cares? If you've gotten access to the queue physically, you can do so much more damage than otherwise. It is not as horizontally scalable as I said before. You're basically doing a cluster deployment, kind of like a MySQL cluster. Also, one of the major griefs that I've heard about RabbitMQ is diagnosing problems in the queue is nigh impossible because you can't see anything. The APIs are basically backend or WSGI. The clients use the requests modules. So these are modules in Python. There are many SDKs out there. Rackspace supports a whole bunch in a number of languages, so if you're attacking them, those are the methods. So this is the actual config drive thing I was talking about earlier. It provided the potential for a compute host compromise via the hypervisors without escaping the hypervisor. Basically, you could inject things back into the host that was providing the config drive. Storage and memory. Okay, so volumes, block storage, and memory are recurring problems in cloud. These are probably one of the biggest areas of, I guess, headaches for us. People forget to zero volumes. People remove code for zeroing volumes when they're coding. This recently happened in the Grizzly development cycle where someone removed the zeroing code from the volume creation code. And then someone, of course, added it back in going, what are you doing? Early Nova actually didn't zero volumes. Amazon didn't zero volumes for a little while. So that's one of those ones you have to watch out for. Volume encryption is coming in Grizzly, so you can have an encrypted volume, so it'll be encrypted at rest. Shared memory space is bad in some ways. I've heard stories of people actually basically continually pulling their over-allocated memory locations and pulling up other people's chunks of memory depending on hypervisors and clouds. So another thing to watch out for. And DMA access by virtual machines is an area of research. I stumbled across a project, again, called Nova at Intel. That's actually a Nova hypervisor that actually is focusing on doing shared DMA access. Okay, so as far as authentication is concerned, the auth tokens originally used UUID version 4 and dev-random off the Ubuntu instance hosting Keystone, which actually provided a pretty good amount of entropy. PKI certs are coming in Grizzly, but I don't know how functional they'll be. We've ran into some serious problems with their token sizes being enormous and causing problems for functionality such as Horizon, which don't know how to handle them. We've also seen DDoSes in other services currently, and they'll probably be in an available but disabled state for the time being until the full Keystone v3 is supported. We'll see. I don't know what we are until the end of this weekend. We're doing a feature freeze. Multi-factor auth is also coming in Grizzly. So until now, we've not had multi-factor auth. So this is an analysis of fulsome vulnerabilities based off of OSSAs. So OSSAs are Openstack security advisories. These are when Openstack makes an announcement about a change with a commit log, CVE, etc., reporting agent. Keystone, Glance, Nova, Swift, Cinder, and Horizon are the main ones. As you can see, Keystone has an undue number of vulnerabilities that were discovered. Glance, not so much. Nova, significant number, but not that important. Swift did great, but that's to be expected. Swift is actually a much older project than the rest of Openstack. Openstack's about 3 years old. Swift is at least 4, maybe more. And here's a lines of code analysis. You can see that Keystone doesn't have that many lines of code, whereas Nova does, and you'd expect Nova to have more vulnerabilities, more code. The question that you have to ask yourself is whether or not there is a correlation between maybe there's more analysis going into Keystone than there is anywhere else, and that's why they're seeing more vulnerabilities. And I don't know if that's the case. I tried to do a analysis by company to see if any particular developer or company was releasing more vulnerabilities. Red Hat kind of was, but not by any significant margin. So I don't see it as being one user's doing better analysis or one company's doing better analysis than anyone else. It's really just a matter of, at this point, the vulnerabilities are being discovered. That could be higher scrutiny in Keystone. It could just be Keystone's just having a lot of flux at the time, and there's a lot more vulnerabilities appearing. But regardless, it's a good target if you want to go looking for things. So this is probably another important component of this. Intrusion detection in cloud is fun. Because it's a homogeneous environment, it's got a whole bunch of weaknesses, but it's also got a whole bunch of strengths. Homogeneity prevents the opportunity to easily identify things that are anomalous. What I have here was a disk utilization reporting tool that I wrote a few years back. And it's a good sample for demonstrating ways to spot anomalies. Var-lib Nova instances is where the instance stores would be. So you would probably want to remove that because on a cloud environment, that would be a massively changing disk volume. But var log is one of those things that should stay mostly the same because you're moving your logs out of there and moving them to a log server and then rotating them pretty often. So if one of these starts to grow, you're probably seeing a lot of stack traces in your APIs. Easy ways to spot problems, easy way to spot somebody doing something strange is there's a sudden burst in logging. Also, you can see like /var grow or something like that, or /home, somewhere where someone might get a user access but not an elevated user access and start dumping files onto the system to try and continue to do more work. You start seeing growth there, you can get an alert and go, okay, this file system shouldn't grow. It's managed by configuration management. If it's growing, that means somebody's manually doing something, and we should go in and take a look and see what they're doing. We've actually spotted other sysadmins dumping stuff into home directories on random servers that they were doing work on, and it's like, you can't do that. And you can also notice that there are nodes here that maybe shouldn't be there. In this particular one, you can notice there's a node without a var log. There's 4 of them. In this instance, that was because those 4 nodes literally did not belong in that cluster. They had been racked, plugged in, and configured by the provisioning system, but they weren't actually designed to operate in that cluster, and we had problems with them, so they were easy to isolate that way. So security APIs, there are several coming. So for intrusion detection, you need a couple of different things. Security APIs help. Event logging is important. Ceilometer is actually a good mechanism for actually pulling decent event logging over RabbitMQ currently. It's being used for billing, but because those events are being logged and they're being authenticated logged, you can actually use it as a pretty decent event monitor. Marconi is maybe going to provide event logging down the line. It's another messaging bus solution as a RESTful API. I don't know too much about it. I just know that it's a potential area for pulling event logging. So as we discussed before, homogeny helps with making anomalies easy to spot, standard methods for precursor indication. Networking, IDSs, and things like that are other good precursor indicators. You probably want that sort of standard fair stuff. External reporting, you probably want a mechanism so that other people from outside can come in and say, I'm seeing weirdness, etc. And security services as SaaS, you can do things as a provider, provide images that allow your users to do testing. So you could have a Nessus node as an image that they could deploy inside of their security group, their tenant, and say, do an analysis based off of what our specs are for this type of application and get reporting. Infrastructure knowledge, I am trying to help you with that with this presentation. And then intrusion response is incredibly important and one of those things that operations guys screw up all the damn time. It's have a plan is the most important thing. You don't want to have an intrusion and then not know what to do. So pounding that into people's skulls is probably the most important thing ever. Also, as a little side tangent, have this in your own life. So if you end up in a situation where someone commits a crime against you, you should have a list of what to do. Who do you call? Because you're not going to be thinking clearly in an accident situation or a criminal situation. All of this is important in real life as well. So consumers need to have a workflow that they know. So if there is an issue, they need to know what's going to affect them and how to respond. Disclosure of breach and other issues should be planned ahead of time. You're probably going to want to talk to your legal and your marketing and everyone else and let them, hide it under a rug somewhere, but have that plan in place. And of course, don't panic. So forensics, I put chain of custody there because that's the key thing with forensics, right? If you're actually attempting to capture someone and make them go to jail, chain of custody is the most important thing there. Most federal agents will tell you things like, don't touch anything, call us, and we'll help you with it because they know how to make sure things get logged properly. Many hands on something means it's no longer admissible as evidence. Ephemeral design means interruptions actually expected, so this helps you with actual collection of data. Your users don't expect their instances to stay up in an elastic cloud. They expect them to randomly go away. That's the whole point of doing a horizontally scaling model is if you take a shotgun to a rack, the reality is nothing should be impacted by it. I think my boss had this really great phrase a while back where he said, the old model for virtualization was you raised it like a puppy and you gave it a name, and if it got sick, you nursed it back to health. But nowadays, when you have virtualization in the elastic cloud and a system gets sick, you take a shotgun to it and you put it out of its misery and raise another one, like cows. So that works pretty well. Okay, so ephemeral design, pretty great. OpenStack has no mechanism for migrating instances between tenants at this moment. This is something that you can kind of do with Nicira in terms of the networking stack, but it will be useful down the line. I know that some SOC teams would like the ability to take a live instance and migrate it into a tenancy that they control and get access to, say, different networking diagnostic utilities and so forth. It depends on who your SOC team is. I know this was a request at one of my former employers. They like to be able to see a live compromised host and actually see what it was doing before they shut it down or image it. So alternatively, you could provide your SOC team access to the tenancy where there's a compromised instance and let them do their thing. Instances can be snapshotted, so you can snapshot a running instance and have an image of it that you can export and send off to whoever wants to dig through that instance and look for vulnerabilities, et cetera, or what they were trying to do. And logs should be isolated in a DMZ. Everything logging-wise should be going out into a one-way locked DMZ that you shouldn't ever have to access unless something goes horribly wrong. This is not your SOC logging. Your SOC usually has its own logging server that you send to and they filter their own way, but you want an actual hard log that's, you know, a long backhaul of all of your logs, tarballed, so if you need to go back and see when something happened a year down the line, you can. And I guess this is the important one for you guys, reporting to Openstack. So there's two ways to report vulnerabilities in Openstack. One is marking something as a security bug in Launchpad. This is similar to the way that Ubuntu does it, and it will go private immediately, and you can have a conversation with the vulnerability management team. If it's extremely sensitive, you can PGP keys and send it to the vulnerability management team members. There are 3 of them. On that URL down there is the list of those members and their email addresses, as well as links to their PGP keys. So these are the 3 guys. No, this isn't. This is something else entirely. Oh, this is a handling of compromised components paper that I read recently. It was very NIST-centric, but a good read. I don't know if any of you guys are federal, but as far as I know, no one's using FedRAMP, so I don't know what you want to do about that. The NIST, however, some people do seem to be following, and doing cloud in FISMA is a pain in the ass. We'll get to that right now. Object storage is a wonderful thing. It's also almost impossible to deploy in an area where you have sensitive data. The reason for that is that overwriting data is incredibly difficult. In a situation where someone accidentally deploys, say, drone videos on a object store that's like a low, FISMA low or something, they'll be like, well, you need to overwrite that right now. That's the nice thing. If you get the phone call saying, hey, you need to overwrite that, you're in pretty good shape. It could be worse. As you can see down at the bottom, what happens if IG shows up, declares an incident, and starts pulling servers out of the rack? Suddenly your object store is missing entire nodes. So that's a loss of data. Doing an overwrite's really hard because it's doing soft replication, so you have to kind of shut down the soft replication, find the actual block where the object store placed the data, and then overwrite it. There's no methods for that currently. It's kind of an enormous pain in the ass. So if you're planning on deploying an object store in a secure environment, good luck. TPM and OpenStack is something that came in Folsom. What it really provides you with is the ability to do trusted pools. And the benefit of a trusted pool is something like if you had an SaaS instance, for instance, that's locked down, you know it pretty well, but it might need a little elevated access inside your corporate or whatever network, you could have them isolated to a specific set of machines based on their authentication over TPM as trusted images when they're brought up. And that's something that exists currently. Some people use it. So this is pretty straightforward, but when you are doing this, you think of your SaaS instances as being more secure than your IaaS instances. If it's an IaaS instance, you just gave root to somebody. So obviously they're going to be able to do some pretty nasty things. SAS, you've given them an application. They're not going to do much with that. PaaS, less secure than SAS, et cetera. That's brainless stuff. Good reading on trusted computing and a presentation about trusted computing put together by a friend of mine. So this is an interesting thing. There's another good reading right after this about isolating isolating data when you're deploying into a cloud environment, much the same way that Apple would isolate fabrication components of the iPhone amongst many different Chinese vendors. So there is a potential for when you're developing a cloud application to put different components in different public clouds so that any back channel break-in from that cloud would not compromise the entire application or any vulnerability in a heterogeneous cloud. And I was going to try and get some information on this for you, but I'm pretty sure you can do it. I'm pretty sure OpenStack can do heterogeneous KVM hypervisors. So in theory, you could do a schedule filter and have different sets of hypervisors and deploy different chunks of your code in a single OpenStack environment on separate hypervisors and provide some heterogeneous defense. But considering public cloud vendors as you would a Chinese fabrication supply chain is probably generally a good idea. You don't know all the time who's running that cloud. You don't know what code's in there all the time. It can be a little dicey. So this is a very, very interesting paper. And that's it for the presentation. So I have 10 minutes left. Does anyone have any questions, anything they want to ask, anything in particular?
Can you just show the location of the PDF at the beginning just while you're doing it?
Sure. That's a good idea. I don't know why that does that, but there you go. So there's the PowerPoint. Shoot.
You had a slide that stated that software as a service is probably more secure than infrastructure as a service. Can you elaborate that?
Well, if you're giving an IaaS. Okay. Repeating the question. I stated earlier that SaaS is probably more secure than IaaS. So why is that maybe the case? Basically, it's a surface area thing. If you've given someone an IaaS instance, they have root, which means they have access to the user network space behind the instances that are running. They can do whatever they want. They can compile code, bring in their own applications, do their own sort of fuzzing of the area behind the application. Whereas if it's an SaaS instance, it maybe just has a public IP, and you can just hit just this, or maybe not public IP, but a different network zone IP, where you can only see it on that zone. Once you're on the instance, you have access to the internal tenant network. Shoot.
In terms of the applications within OpenStack that make the architecture, how much, if any, has deployment around, like mandatory access controls, like an SE Linux policy for those components, or testing with like hardened like GR security kernels, or we're kind of working at the host level to deploy those apps securely and keep any breaches from going out to other components.
Okay, I'm not sure how I'm going to repeat that question, but I guess mandatory access controls and deployment models built around ensuring security. Are you talking about at a deployment site or in the actual development of OpenStack?
No, deployment site.
Okay, at a deployment site, it ranges. What I have seen is most folks are doing their own independent needs assessment. A lot of people currently are not at the point where they're actually at that policy level, and OpenStack, in my opinion, probably isn't 100% ready to do something like go for a FISMA moderate or high, or go for a Sarbanes-Oxley full compliance, PCI compliance. But people are going to write their own code and make it work anyways. Right now, what you're seeing is a lot of people are doing small-scale deployments, 1 rack, 2 rack, 3 rack. The public cloud providers are functionally different. They're doing their own security model that's, a non-security model. We tried to in the early days of the first OpenStacks, Austin and Bear, we were trying to achieve FISMA moderate, and what we did is we just worked closely with the SOC teams in the continuous integration process, and they saw what code we were putting in. They were able to file bugs against our feature request as part of the sprint planning. They would sit there and go, we need these by the end of the sprint, and we'd complete those tasks. There was also a policy guy in the team who would, ensure that everything that we were doing solution-wise would meet policy requirements. We do unit testing. You can do that as well. That's what the Jenkins workflows are for. Any other questions?
Can you talk about what's coming in Grizzly or what trends you see in data investigation, whether at the persistent or malicious level or the object store level?
Okay. The question's related to what am I seeing coming in Grizzly in terms of data at rest encryption and where that's going. A lot of people seem to be into it. I think that's more of a policy thing. Data at rest encryption is something that a lot of people require. I don't know that it's entirely useful in a situation like this, because if that data is accessed and it's no longer at rest, which is most of the time in a cloud environment, it's now available via shared resources, usually shared pools of memory, shared volumes, shared CPU structure. It's a question. I think it helps. Like anything, it's not a fix-all, but it does help. And there is more work being done in Grizzly for volume encryption at rest. Someone was working on image encryption at rest, so when an instance is deployed, it's deployed encrypted when it's in a down state, and when it activates, it gets decrypted and brought up. And you can do stuff like that with TPM. So people are working on it. Any other questions? Yep.
For the multi-factor coming in Grizzly, do you know how they're implementing? Is it going to be standards-based, like P, or are they going to be pluggable, like for duo auth or phone factor or stuff like that?
I think it's a tie-in to auth and authz, and to be perfectly honest, the best way to get information on this is to look up Adam Young's blog. So.
The internet's wondering if formal code reviews are being performed, and what about the Openstack security group?
Okay, the internet's, do I have to repeat that? Okay, so the internet's wondering about formal code reviews and what the security group's doing. The security group ostensibly is supposed to be charged with doing things like internal audits of the open source stuff, doing vulnerability analytics, which is why I'm here today. And we'll probably have a conversation about how to go about doing better automated testing through Jenkins for vulnerabilities and ensuring that our methods operate as intended. 2 or 3 of our keystone vulnerabilities were merely the method calls in our API didn't work as intended. So we had it documented what it's supposed to do, but no one ever actually checked to see if it did that. So several of our vulnerabilities could have been spotted if somebody had actually gone in and checked to make sure that the method calls worked as intended. There are code reviews automatic as part of the continuous integration process. Whenever you commit code, at least 2 other people see that code, look at that code, comment on that code, and approve that code going in. Usually it's more than that. And if it's something important, it's usually like 15 people. I think we're running out of time. Is there any last question? Nope. Okay. Hopefully you guys enjoyed this. Hopefully you got something out of this. And if you want to get involved, get involved. It's an open source project. It's a great way to get a job. Cheers.